As discussed in previous chapters, you will encounter many situations in which a sample will be taken from a population and you'll be required to analyze the sample data. As we saw in Chapter 1, there are several different statistical sampling techniques, including random sampling. The objective of a random sample is to gather data that accurately represents a population. When analysis is performed on the sample data, the results will be as though we had worked with all the population data. Here are the key learning outcomes for Chapter 7. After this series, you should understand the concept of sampling error and how to compute it. We will determine the mean standard deviation for the sampling distribution of the sample mean x bar. We will cover the central limit theorem and finish off by computing the mean and standard deviation for the sampling distribution of the sample proportion p bar. Regardless of how careful we are in using a random sampling method, the sample may not be a perfect representation of the population. For example, a statistic such as x might be computed for sample data. Unless the sample is a perfect replication of the population, the statistic will likely not equal the parameter. In this case, the difference between the sample mean and the population mean is called the sampling error. In this case, in which we are interested in the mean value, the sampling error is computed by taking the difference of the sample mean and the population mean. Remember back to the difference between a parameter and a statistic. A parameter is a measure computed from the entire population. As long as the population does not change, the value of the parameter will not change. When we select a sample, we need it to be random. A simple random sample is a sample selected in such a manner that each possible sample of a given size has an equal chance of being selected. We learned in Chapter 3 that a population mean is denoted by the Greek symbol mu and the sample mean is denoted by x bar. If we are given these values, or we calculated them from the data, we can determine the sampling error. In this case, x bar is 99.2 degrees and mu is 98.6 degrees. This random sample of 5 temperatures yields a sampling error of 0.6 degrees. In sum, remember 3 fundamental concepts about sampling. 1. The size of the sampling error depends on which sample is selected. 2. The sampling error may be positive or negative. And 3. There is potentially a different sample mean for each possible sample. Go ahead and open Excel file Dow Jones and answer the following questions. To calculate the population mean for the closing values, we'll use the equals average function and select the closing range. Now we want to select a sample of 10 values. So we use data analysis, and use sampling. And there's our 10 values. And let's take the average of our sample of 10. So we can see it's significantly different than the mean for the population. So now we can determine the sampling error by taking the sample mean minus our population mean. So in this case, we got a sampling error of 540.68. Now let's go ahead and do the same thing, but this time we're going to find a random sample of 50 and a random sample of 100. Again, computing the sample mean and the sampling error for each sample. Okay, so here's my sample of n equals 50 and our sample of 100. Go ahead and compute the x bar and determine the sampling error for each of these samples. So we can see as n increases, our sampling error decreases and the sample mean approaches the population mean.